Okay, so I did this example with you. Now I want you to do this example on your own. So pause the video, write theta as a function of x. Unpause when you're ready to check your work. Okay, so since we have theta, we have an adjacent, and we have a hypotenuse, I used cosine, so we can say cosine of theta is 4 over x. We aren't solving, we are just writing theta as a function of x. Therefore, I rewrite this as theta equals the arc cosine of 4 over x. Alright, next, write an algebraic expression that is equivalent to the trigonometric expression. What does that mean? That means here is a trigonometric expression. My result, in the end, is going to be an algebraic expression that does not have any trig functions in it. How do I do that? Draw a triangle. So if I call this theta, arctan of x is telling me this side is x and this side is 1. Using the Pythagorean theorem, 1 squared plus x squared equals y squared. So y equals the square root of 1 plus x squared, because 1 squared is 1. So this side is the square root of 1 plus x squared. So what is the sine of theta? Sine is opposite over hypotenuse. That is an algebraic expression that's the equivalent to the trigonometric expression. I did not rationalize the denominator here because I have variables in the denominator. We want to rationalize whenever we don't have variables. So if this was just numbers, then we rationalize. But with variables, don't bother. Alright, so I want you to do the same thing here. Secant of the arcsine of x minus 1. So I want you to write an algebraic expression that is equivalent to that trigonometric expression. Pause the video, do that, unpause when you're ready to check your work. Okay, so first I drew a triangle here in black. Sine is opposite over hypotenuse. I use the Pythagorean theorem to find the missing side, and then I evaluate this angle for secant. Secant is hypotenuse over adjacent. So your algebraic expression is 1 over the square root of 1 minus the quantity x minus 1 squared. Okay, so our conclusion here is our strategies for evaluating the composition of trig and inverse trig functions. Evaluate the inside part first. Use the unit circle whenever you can. Otherwise, draw a triangle. Last resort is the calculator. Once you evaluate the inside part, then evaluate the outside part. Always paying attention to whenever you are evaluating an inverse or arc function to check the domain and range, or to be aware of the domain and range. Also, hopefully, in going through this set of notes here, you are starting to realize how important it is to be able to efficiently and effectively use the unit circle. If you are struggling with that, again, please talk to me in class, because that's going to be a big part of this.